Hello and welcome to another water drop workflow video where we're going to be looking at the tools within InfoWorks ICM to calculate the total live and dead storage in an InfoWorks ICM network. So who's this for? Utilities and engineers that just want to gain a better understanding of where issues could lie related to H2S or hydrogen sulfide buildup in the system. That would be the dead storage in this case, where water is just kind of sitting in areas and not being able to get flushed out. Also, InfoWorks users just wanting to increase their usefulness of the software using some tools they might not know about, and then also understanding with engineers and utilities to know where to focus when you're running the model, just making sure that areas are getting a sufficient amount of flow so that they are flushed out and don't run into those H2S problems in the actual network. The workflow here is going to be looking at the running the total storage tool in InfoWorks and describing some of the inputs and what we're looking at. And then finally pulling up the results. It comes up in a graphical format. We've also get some text feedback as well, so we're going to interpret kind of what those different pieces mean and how we can use them. So here I've got a relatively simple sanitary sewer model where I've got force mains over here, but a majority of this is a gravity system. The first step in all of this is going to go up to model, and then in storage operations there is this total storage calculation where we have a couple of different parameters we need to input. This calculate the storage below. It defaults to the highest storage level in the system. We can also split between live and dead storage in our graphs that we get off. What this is basically if a conduit is able to drain to either a wet well according to where the pump level off is, or to relative outfalls, that's essentially where it's draining to. We're going to generate that storage graph. I also want to save the storage results in the user number field. So one is static or total storage, live storage, dead storage, and then the drainage level, which is essentially a trace of from the conduit to wherever it's draining, whether it's that wet well or an outfall, that lowest point it's able to drain to. If it's not able to drain, then it will just be blank for us. So we're going to go ahead and run that. Once that completes, we do get that graph that we're looking for. So we do have the storage and storage nodes and the manholes, as well as the conduits in the total. This is the total here. We're up at about almost 15 million gallons for the total storage in the system. I can also use the arrow keys to toggle through some additional graphs here where we've got the live storage in each one of the storage manholes or conduits in addition to the total. If you flip back and forth through there, you can see a little deviance between the two. The third one is going to be our dead storage in the system, and as you can see from the y-axis here, we've dropped down pretty significantly from where we were, where the y-axis was a maximum of 15 million gallons down to now we're at probably 0.25 million gallons. So that's the amount of dead storage we have in the system. If I go back to my network and pull up the links window, I can scroll over to the right side here. And again, with the user numbers, I have those populated with the total storage, the live storage, the dead storage, as well as the outfall, the drainage level that it would get to if you were tracing through there. If you didn't want to forget what these columns mean, we can click up here at the top here and then set heading for this column. So I can say total storage and then do that for the rest of them. Alright, so now we've got everything labeled here. I'm going to first take a look at my dead storage and going to sort ascending on this. So we can see we have a couple of conduits in here with some pretty significant amounts of dead storage here. Again, these are in millions of gallons. So 1, 2, 3, about a good amount of dead storage in this case. So I'm actually going to just zoom to this, select and find in the geoplan. So I've got this pipe network right here. I'm going to go ahead and select a couple more of these conduits, and then pull up a profile view of what we're looking at. So we can see that first one that we have in there, this is why we have that dead storage, because we have that adverse slope here, that back slope coming from the system. So as this is filling up until it gets to the 693 point, we're not able to drain, so all this area in here would be considered dead storage, where we could see some of that buildup of hydrogen sulfide gas in there. Once you do kind of get an idea of where maybe problem spots are, you can then run the simulations and just make sure that water's enough dry weather flow is coming from the different subcatchments in order to flush out those areas efficiently. So wrapping up here, this is really just a quick, simple tool, pretty short video here, looking at potential problems that might be in the system, maybe something that isn't really well known. You can use this in conjunction with simulations to evaluate kind of the true risk and what you're really looking for. Again, just making sure that some of those areas with a lot of dead storage are getting flushed out. And then, as always, please feel free to reach out if help is needed.